Grady's birthday this weekend. All right. Okay, so here we go. I didn't even make you fill any of this in. It's ridiculous. The second derivative test is another way to find max and min. So what confuses people is the second derivative tells us concavity. So they think the second derivative test tells us concavity. It doesn't. The second derivative test says if we know a critical point from the first derivative. So if we have some critical point where the first derivative at that value equals 0, and if you can take the second derivative, then when you plug that critical point into the second derivative, you can tell whether it's a max or a min. Because if the second derivative at that critical point is greater than 0, then that means that that graph is concave up. Does that make sense? Because the second derivative is greater than 0. And if you know it's a critical point, then if you drew a thing that's concave up, and you know the critical point is where the first derivative equals 0, then that means that it's a minimum graph, or minimum on the graph. But it's where the first derivative is. I don't know. We'll do one. So, if you plug it into your second derivative and you get that it's positive, it means it's concave up. Concave up where it's a turning point would have to be a minimum. Does that make any sense at all? And if the second derivative is less than 0, means concave down. But again, if you're plugging in the critical point where the first derivative equals 0, then concave down at a turning point would have to be a relative maximum. But here's why I get most frustrated with the second derivative test, is because sometimes when you plug it in, it also equals 0, which means the test fails and you have to go back to the first derivative test anyway to see what's happening. And so it's kind of annoying because you do the work and then you get a 0, and if it's the first derivative equals 0 and the second derivative equals 0, not always, but oftentimes what happens is that ends up being an inflection point. It's not really a max or a min, but it's an inflection point. But you have to go back and check and see what's happening with the graph. So this is the part that I think makes me annoyed. What usually makes my students annoyed is they just think that it's a hassle. To me, this is only helpful if the second derivative is really easy, right? I don't want to do the quotient rule for a second derivative. I don't want to do a really complicated second derivative. I'd rather just do my first derivative test. But if it's an easy second derivative, this is probably less work than making your little chart and plugging in your numbers. So we're going to practice this on a couple today. And again, I'm never going to force you to use the second derivative test. I just want to show it to you. And then really the majority of the notes today are just kind of putting it all together. So I just have two examples here with the second derivative test. And I would encourage you today to try it, just to try it out. But if you really think you're never going to use it and you want to automatically go back to our intervals, you could. But like polynomials, this one's great to do because if I took the derivative here, I would get 3x squared minus 12. Extrema, right? So I'm trying to find where my derivative equals 0. 3 out of that, right? I would get critical values of plus or minus 2. Agree with that? So, old way, first derivative test, we could draw a line, we could check on either side of plus or minus 2. Still going to work. Second derivative test says, well, is it easy to take my second derivative? And this one it is. Because I would just get 6x. 6x. So that's really easy second derivative. So the second derivative test says, now plug in your two numbers, and you're just looking to see whether you get a positive or a negative number to see whether that critical point is concave up or concave down, so you can see whether it will be a max or a min. So if I plug -2 in there, I would get negative 12, which means that that graph is concave down, which means I know that that is a relative max. The tricky part is negative means max because it's concave down, so you have to kind of, that's why I always draw a picture. Did you notice I had a new microphone? Jacob Maynard fixed it up for me on Friday because they're like making fun of my broken microphone, and I was like, I bought a new microphone, but it doesn't work. And he's like, what do you mean it doesn't work? And I said, I plug it in and it won't record. He's like, I can fix that. Want to see it sounds better. It looks better. So if it's positive, it's concave up. Relative. Is it less work? I don't know. Sometimes. The next one might not be. If it says find relative extrema, am I done with this problem? I gotta find the y values to go with it, right? So 12, negative 12 are not the y values to go with it. Those are my second derivative values. So I would want to say there's a relative max at negative 2, find the y value, and a relative min max 2, find the y value that goes with it. So if I plug negative 2 in there, I get negative 8 plus 24 minus 5. Negative 13 plus 24. 11. And so relative min, and I really want to encourage you to do this. I know you're so used to using calculators, but half of that test is without a calculator. So we want to like get better at our arithmetic skills that we maybe have gotten lazy with in the last few years with our calculator dependence. I don't know how many AP questions I've missed because of studies. Negative 21, is that true? Study math weirder than you would have done it. I always put the same signs together when I'm doing adding and subtracting. So like on this one I did my negatives together, and on this one and it's okay, whatever order you did it in would be the right answer, but that's just how I get it. Yeah, I know. I go with the sign. Positive. Okay, now we're done. Alright, so we better do one that's not so pretty, right? So what do you gotta do here? Product roll. Go, start with that one. Not that complicated. Let's do the U. You always do. That. So I just went ahead and changed my plus to minus because the derivative of negative x was negative x. And so just like we did this before, when you set that equal to 0, you can just factor out the e to the negative x. And is e to the anything ever going to equal 0? E to the negative x, like, that flips it over now, but it still has that horizontal asymptote. So e to the negative x is not equal to 0. Just x equals 1 is our critical point. Questions on how I got that? So honestly, if I'm being honest with you, would I do the second derivative test on this problem? I wouldn't, because there's only one critical point. It's not going to be that hard to check on either side of it. But just for fun, let's just do it just on this one, because it's the first day we're doing it, because we can practice our derivatives. So here's my question: do you want to go back up here and take the derivative, or do you want to take the derivative like this? It doesn't matter. It's just your choice. Just go back up here. Up here. Sometimes it's just fun to practice. Here's another reason why second derivative tests are sometimes hard. But if they ask you to find relative in any function question, you're going to have to take the second derivative later. And so that's another reason that I already did it, I might want to start the value. So that's another reason that I do it. So e to the negative x, oh, I found myself, that would be negative e to the negative x. And then that would be minus e to the negative x. Oh, we got to watch our subtraction signs here, right? So then that would be plus x e to the negative x, because that's already a minus, and then when I pull the minus out from the negative x, the two negatives make positive. Agree with me on that? Gotta be careful. So it's like a negative 1. If you really wanted to clean this up, we could say that's negative 2 e to the negative x plus x e to the negative x. E to the anything, is it ever going to be negative? No. So it's just looking at this, negative 2 plus 1. So that's going to be negative. Do you agree with me on that? Because that's always positive. Negative 2 plus 1. So negative means concave down. So we can say that there's a relative max at 1. Plug it back in. Yeah, we plug 1 in there, it's just e to the negative 1, which you can write as e to the negative 1, or you can write as 1 over e. Okay, so that's the second derivative test, whether or not we use it very often. I can honestly tell you by the time we get to the AP test, we review the second derivative test. And I with you, I usually do the signs too. But again, sometimes it's especially if you were checking it out. So, I shouldn't tell you. Alright, so let's kind of use what we learned now about first and second derivative. Putting it all together. Look at these lovely graphs I've drawn here. And think about for a minute, if that is f of x, I want to know, what can you tell me about f prime of x and f double prime? So again, just kind of thinking about, what does this graph tell me about what's the connection between the function and the derivative and the function and the second derivative? One or the other? What do we know about what does the first derivative tell me about the function? Or what does the function tell me about the first derivative? The decreasing function, and decreasing functions mean that my derivative is negative. That's the chart that we make, right? When we put a minus sign, that means that. So because this is decreasing the whole time, we can say 0. And what's the connection between the function and the second derivative? What are we talking about? Concavity. And what is this graph? Concave up, concave down. Concave down, so the second derivative is. I'm going to find one of these questions for the packet I give you tomorrow. But the last couple years, there's been a question on the release exam. And just so you know, the release exam that they give us is the international exam, which is what everyone else takes, not the United States. So it's not the exact same test that you guys take, but similar. And what they've done is they've given a function, and then they give an f prime and f double prime, and they put them into inequality, and they ask you to pick which one's right. So like one of them will say f of x is less than f prime of x, which is less than f double prime of x. Now there's like all the options. F double prime of x is less than f of x, which is less than f prime of x. And you have to figure out what you know about all of them to eliminate them. So not as simple as this idea, but still making you make that connection. All right, someone else tell me what you know about number 4. Looking at this graph, what can you tell me about the first derivative? Because it's increasing. And what about the second derivative on this one? It's equal to 0, because if you took the second derivative of a linear function, you're always going to get 0. No concavity. Right? So on this next slide, this is my own little made-up slide. We don't really have to write a ton of stuff out on here, but I'm trying to get the connections here, because if you can make these connections, I'm telling you, we could go through an old test and I could probably pick out 15 questions. It's a lot on the whole multiple choice that have to do with the relationship between the function and the different things we haven't done yet in terms of integration, but the relationship here. So the critical points of your function, right? What do we do to find critical points? You set the derivative equal to 0 or undefined. And when you look at the graph of your derivative, where it crosses the x-axis, the x-intercept, what do you know about that? Intercept. Is that just where it also crosses 0? Or you could say, hey, that's what this is. That's what this is, right? The critical numbers of your function are the x-intercepts of your graph, of the derivative. Or the x-intercepts of your derivative graph are the critical points of your function, your relative extreme. So what about the next one? Look how I've grouped them in twos. You're going to see a pattern emerging here. The inflection points. How do we find inflection points of our function? What do we do to find inflection points? At what? Second derivative equal to 0 or undefined. And if we were looking at a graph of the second derivative, where it crosses the x-axis would be where the second derivative equals 0. So if you're looking at a graph of the second derivative, the x-intercepts are the inflection points of the function. So look at the next one. I don't know that you'll need to write stuff after a while. But where is the function increasing? The function is increasing when your derivative is what? Greater than 0. Or is another way of saying when my derivative is greater than 0 is when my derivative is above the x-axis. So if I'm looking at a graph of the derivative, everywhere that it's positive, everywhere that it's greater than 0 is where my function is increasing. So those are the same thing. The same thing. And the next thing, right? What are we going to write differently here? Where is my function decreasing? When my derivative is less than 0. So if I was looking at a graph of the derivative, less than 0 is when the y values are below the x-axis. So where f prime of x values are below the x-axis, aka where the derivative is less than 0. The same thing. 9 and 10, 11, 12, same thing, except we're talking about concave up and concave down. Right? If I'm talking about concavity, I'm talking about the second derivative. So concave up is where my second derivative is greater than 0, or where my second derivative is above the x-axis. I'm just going to go here. Concave down is where my second derivative is less than 0, or where the values are below the x-axis. And then probably one of the harder ones of comparing is when we talk about, if they give me the graph of the derivative, what do I know about the second derivative? And we'll look at some of those tomorrow too. You guys did great last Friday when I gave you that. Someone made the connection that if I'm looking at the derivative graph then its turning points are inflection points, because that would be where the second derivative equals 0. So let's see if I can write that. Relative x and on f prime of x are inflections on f of x, or that's the same as saying it's where f double prime of x equals 0. We could also talk about whether what's happening with the second derivative by looking at the first derivative. You have to practice that. And we'll kind of come back to this in a minute. When we review the AP exam, I give you this exact same slide because I just get the example of how these function f prime and double prime are. Look at the last one here. This is my last one. It's not supposed to be super hard, but there's more than one answer here as long as you meet the requirement. So let's just kind of read through this. It says sketch a smooth curve through the origin, so that's really important, that has these properties. So f prime of x is less than 0 when x is less than 0, and f prime of x is greater than 0 when x is greater than 0. So it's just kind of asking you, 1, can you read this notation? And 2, do you know what it's telling me about the graph if they're telling me stuff about the derivative? So, does somebody want to come up here and draw this? I know you do. I'll do the first part. What does it mean that the first derivative is less than 0 or x less than 0? What does it mean when the derivative is less than 0? What does it tell me about my graph? Slope is negative, aka it's decreasing when x is less than 0. So your graph has to be decreasing on this side. And that the derivative is greater than 0 when x is greater than 0. So that means that it's increasing on this side. It does say that it's a smooth curve, which is telling you that there should not be like a point, like you shouldn't have made an absolute value graph. That's not really a smooth curve, right? A lot of times it'll say like make a differentiable function, something like that. So, right, that's not meant to be a hard problem, but it's kind of just doing more than just finding critical points. It's making you kind of put that all together. Question? That's it. That's my notes here. 4.3 day 3. This is your last book assignment besides the chapter review before we have a test. We aren't having a test until Monday because we are going to do a lot more with that this week. But if you're behind on homework, please catch up. We will have a homework quiz this week. And today I'm just giving you 33 through 39 odd, 41, and 46. You have some time to work. So if you still have unfinished homework or you still have questions from previous homework, please ask me so that we can talk about it and before we go on and